We are going to walk through an example where we are going to use reduction of order to find a second solution that we're going to call y2 to a second order differential equation, x squared y double prime minus 3xy prime plus 4y is equal to 0, given that we already know one solution, y1 is equal to x squared. The first thing that we want to do is put the equation that we've been given into standard form. Let's start by writing down that equation. It's x squared y double prime minus 3xy prime plus 4y is equal to 0. To put the equation in standard form, all we have to do is divide by the variable or coefficient that multiplies y double prime. So we're going to divide everything by x squared, and that gives us y double prime minus 3x over x squared times y prime plus 4 over x squared times y is equal to 0. Let's simplify this, and we get y double prime minus 3 over x y prime plus 4 over x squared times y is equal to 0. In step 2, we're going to make a substitution that y2, that's the solution that we want to find, is equal to u times y1, and y1 is the solution that we already know. For our example, we are going to let y2 equal u of x, so I'm just going to call that u, times y1, which we were given as x squared. What we're going to do now is we're going to take y2 and substitute it back in to this equation. We can do that because the solution to this equation is y is equal to c1 y1 plus c2 y2. Before we plug it in, we need to find y2 prime and y2 double prime, so let's go ahead and let's do that. y2 prime, using the product rule, is the first times the derivative of the second plus the second times the derivative of the first. Now let's take another derivative. y2 double prime is going to be the first times the derivative of the second, which is just 2, plus 2x times u prime. Now let's look at the x squared u prime. Using the product rule, it's the first times the derivative of the second, plus the second u prime times the derivative of the first, which is 2x. Let's go ahead and let's simplify this. This is x squared u double prime, and then we have a 2x u prime and another 2x u prime, so that is 4x u prime, and then we have a 2u. Let me highlight these because these are the ones that we are going to be substituting back in to our equation. Now we can do that. Let's draw another arrow here. This equation is now x squared u double prime plus 4x u prime plus 2u minus 3 over x times y2 prime, which is 2xu plus x squared u prime. A lot of algebra here. Plus 4 over x squared times y, which is u times x squared, and all of this is equal to 0. Now let's go ahead and let's simplify. This gives us x squared u double prime plus 4x u prime plus 2u minus 6u, the x's cancel out, minus 3x u prime plus 4u is equal to 0. Now let's combine everything. We have an x squared u double prime. We have a u prime here and here. So this gives us a plus x u prime. And then we have a 2u, a minus 6u, and a 4u. So 2 minus 6, that's minus 4, plus 4 is 0. So the u term goes away, and that's equal to 0. Reduction of order is designed so that the u term always goes away. Let's highlight the equation that we got before we go on to the next step. That next step is that we are going to make another substitution. we're going to let w equal u prime of x, and then we're going to solve for w. Let's write this down. We have w is equal to u prime, and that means that w prime is u double prime. Now we're going to take the equation that we got in step 2, and we're going to substitute in w and w prime. We have x squared times u double prime, so that's now x squared w prime, plus x times u prime, so that's x times w, is equal to 0. Notice that this is a first order equation, and our equation for u up here was a second order equation. This is why it's called reduction of order, because we're reducing a second order equation to a first order equation. Let's look at this one and see what method we would need to use. It's a little bit hard to tell until we simplify. Let's divide each term by x squared so that we can see what it looks like. So we're assuming that x is not equal to 0. Let's go ahead and let's bring the w to the right. So we have w prime, which I'm going to write as dw dx, is equal to minus 1 over x times w. Now it looks like we can solve this using separation of variables. So let's go ahead and let's do that. Let's write this as 1 over w dw is equal to minus 1 over x dx. Let's integrate both sides, and we end up with natural log absolute value of w is equal to minus natural log absolute value of x plus an arbitrary constant c. There are a number of ways we can solve this. I am going to exponentiate each side of our equation so the natural log can go away. So this is e to the natural log absolute w is e to the minus natural log absolute x plus c. On the left, we have absolute value of w. And then on the right, I'm going to rewrite this as e to the c times e to the natural log x to the minus 1. So what we did here is we assumed that e to the a plus b is e to the a times e to the b, and that a times natural log u is equal to natural log u to the a. Now we can say that absolute value of w is equal to e to the c times absolute value of x to the minus 1. Let's get rid of the absolute values and put in a plus minus instead. So we can say that w is plus or minus e to the c times x to the minus 1. Now let's let this complicated constant just be c1. So we get that w is equal to c1 all divided by x. So we did it. We solved for w. Now let's go up to the upper right and look at step 4. For step 4, we want to solve for u of x. So let's remind ourselves that u prime of x is equal to w of x. And we just found that w was c1 divided by x. So u is going to be the integral of c1 divided by x dx, and that is just c1 natural log absolute x plus c2. Now let's go ahead and look at step 5. That is our last step, and we need to solve for y2. Let's write down that y2 is u times y1. So this gives us y2 is u, which is c1 natural log absolute x plus c2 times y1, and y1 was equal to x squared. So this is c1 x squared times natural log absolute x plus c2 times x squared. Now there's only one thing left to do. We need to figure out what we want to pick for c1 and c2. Notice that c2 x squared is just c2 times y1. We already have y1, so we don't need another multiple of y1. So we're going to choose C2 to be equal to 0. And then let's go back up to the top here. I want to show you something. Up here on the right is our solution for y. Notice that our solution y is C1y1 plus C2 times y2. Let's go back down to the bottom and let's think about this constant right there. We don't need our solution y to be C2 times C1 times x squared natural log x. So we're going to choose that C1 is equal to 1. This gives the solution y2 is equal to x squared natural log absolute x. And there's our second solution. Now let's put it all together. Let's go back up to the top and let's write down what y is. We'll put it right up here. Y is equal to C1 times y1, which is x squared, plus C2 times y2, which we just found to be x squared natural log absolute x. And there's our solution for y. And that's it. You now know how to use reduction of order to find a second linearly independent solution to a second order linear differential equation when one solution is already known. You should now be all set to work through some example problems on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.